Hello friends, this video on structure of atom part 19 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 18. Now let's understand the Bohr model of atom. So if you see, by the time Bohr was designing the metal, there were two things that were hot in the market. One was the dual nature of electron. The second was the spectrum, which nobody knew how it comes. So Bohr took care of the spectrum, but he didn't take care of the dual nature of electron. We'll see what he has done. He uses the emission spectrum of hydrogen. That was the base for him to develop the model for hydrogen. And he postulated that electron moves around the nuclei in circular orbits. For example, if you see, this is the nuclei, and he's telling that this electron moves around this nuclei in the circular orbit. They are fixed circular orbits and moves around that. Also, Bohr was able to determine the radius of each electron in the orbit. Please note, he's talking about the orbit, which actually is not there today. But we are now learning the history of chemistry, so we are learning orbits, but actually there is nothing called orbit in terms of atoms in the real world. If you see an atom, you won't be in orbit. But he postulated that there is something called orbit, and he was telling that I can tell you the radius of the orbit, and the electrons moves around this orbits in the circular fashion. And he also told that he also calculated the energy of electrons in these various orbits, right? And he also predicted the distance between electrons and nucleus. And he also offered a satisfactory explanation of the spectra of hydrogen. What he told was each orbit has specific energy. So let's suppose this guy has energy 1, this guy has energy 1, E1, this orbit has E2, and this has E3. That energy is fixed. So when an electron jumps from here to here, it emits spectrum, it emits light. And that's what the spectrum is all about. And he talked about the quantization of spectrum and all. We'll discuss all these things. Just understand that he offered a satisfactory explanation for the spectra of hydrogen. We'll learn what was that. And also he told that only certain orbit can exist. And each orbit corresponds to a specific energy, and energy is quantized. I'll tell you what the quantization means. He's telling electron energy is quantized, and all these orbits, right, they're only specific orbits. They're only specific orbits. N is equal to 1, 2, 3 like that. The electrons move in the orbit. That's what he told. This is a very basic explanation, but actually it is not this way. The actual explanation is the quantum model of atom, which we'll discuss later. But just now understand the work which is done by Bohr. It was a very good achievement because the best part in this explanation was the quantization of energy. The quantization of energy, this is the best part which he has come up, and which is still true. Right? He told the energy is quantized, and we see that in the quantum model also. You see the energy is quantized. But other things which he has told that electrons moves in the orbit, and those things are wrong because the orbit doesn't exist. We'll see that also. But now let's see what is photo emission. So an excited atom move from high energy to low energy, and this emits a photon, and a lot of photons makes a spectrum, right? And then we can determine the difference of energy between the levels by measuring the wavelength of the photons emitted, because delta is nothing but, we have learned SC by lambda. If you know this value, so if you know this wavelength, we can also find the difference in energies of two different levels, right, by using the formula SC by lambda. Now let's understand the quantized and continuous spectrum. So when you say continuous spectrum, delta E can have any value. But when you say quantized spectrum, delta E will have only certain values. To understand the layman term, for example, in this case, right, this student can go from here to here also, right, 1 to 2 or 1 to 3, any point it can move, right? But if you have made steps, this person can move only one from 1 to 2 or 1 to 3, right? there are only 4 steps now. The possible combination is, if you mark this as 1, 2, 3, 4, this can move from 1 to 2, 1 to 3, 1 to 4, or 2 to, if you're planning to move upward, 2 to 3, 2 to 4, or 3 to 4. Only 4, these many possible combination is there. It is quantized. If it is not quantized, this student can move anywhere, right? It can move from here, just here, just here, just here, just here. It can move anywhere. So the quantization is not there in this case. So when you talk about continuous spectrum, there is no quantization. Delta E can have only any possible value. But you talk about quantized spectrum, delta E can have only, the change in energy can have only certain values. And that's what Bohr has told, that in case of atoms, the spectrum is quantized. And that's true for today also. Today also, if you see any atom, this is true. The energy is quantized. That means you have different orbitals, and if you see, the evidence for the quantized electronic energy level was a spectra, because this may have come from an electron jumping from one level to another. This may have come from electron jumping from one level to another. These are not there, right? That means this kind of delta E is not possible. Only these many delta E which is there in the screen is possible for this particular metal or element. Hope you understand. When you say delta is quantized, that means only few delta E is possible. That's why you don't have continuous spectrum here. You're getting quantized, you are getting breaks here, because some delta E is not possible. And that's why for that you're not getting photon. Because if there is a delta E, if there is a change in energy, the electron jumps from one level to another, for that you will get a photon, right? And which will have one particular wavelength, and that wavelength will define the color of the photon. So only certain wavelengths are possible, certain delta E is possible. That means the energy is quantized in case of atom, and that is the biggest achievement of Bohr model. He is telling that if you have a nuclei and you have the certain levels, he is telling each orbit 1, 2, 3, let's suppose, this guy will have E1, this guy will have E2, and this guy will have E3 energies. So if electron jumps from here to here, right, the delta E can have only, let's suppose in this case, it can have values like E3 minus E1. If E3 from E3 it jumps to E1, or E3 minus E2, if it jumps from E3 to E2, or E2 minus E1. Only 3 possible values in this case. So for such kind of atom, you will see only 3 lines, and this guy will, delta I will correspond to Hc by lambda. Some lambda it will have. This guy will also have some lambda. This guy also will have some wavelength, and these all wavelengths will be different, so they'll have different colors. So for this case, actually, if you see the spectrum, you will see only 3 lines with 3 different colors, because 3 delta E is possible, and for all these delta E, you will have 3 different wavelengths. That's what the quantization of energy means, and that's the biggest achievement of Bohr model, where he is told that energy is quantized in case of atom.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.